Today I'll be showing you L'Hopital's rule, which is a tool you can use to find the limit of certain types of functions. It's something that you can use when you're looking for the limit of a function divided by another function as x approaches a certain value, and when basic substitution gives you an indeterminate form. And don't worry if you don't know what that means, because I'm going to quickly show you. So say we want to find the limit of sine of x over x as x approaches 0. Well, we can try basic substitution first. So let's try sine of 0 over 0. Sine of 0 is just basically 0. And that's over 0. So now we have 0 over 0. And that's what we call an indeterminate form, because we can't really say what 0 divided by 0 is. So if you try direct substitution and you get something like 0 over 0, or maybe infinity divided by infinity, or infinity minus infinity, 0 times infinity, 0 to the power of 0, 1 to the power of infinity, or infinity to the power of 0, these are all indeterminate forms. So if you get any of these, it means you can use L'Hopital's rule to try evaluate the limit. And what L'Hopital's rule says is that when you're trying to find the limit of a function in the form f of x over g of x as x approaches some value, you can differentiate f of x and g of x separately and turn it into f prime of x over g prime of x. And then you can try to evaluate the limit again. And you can keep doing that until you either find the limit or determine that there is no limit. So let's try that on sine of x over x. The derivative of sine of x is cosine of x, and the derivative of x is just 1. So now we have the derivative of the numerator and the derivative of the denominator. So let's sub x equals 0 into that and see if we get a limit. Cosine of 0 is just 1. And that's just over 1. So 1 over 1 equals 1, which means that the limit as x approaches 0 is 1. So L'Hopital's rule is for a function divided by a function, but you might remember that a lot of the indeterminate forms I showed you weren't in the form of a fraction. So let's quickly go through an example that deals with that. So here we're looking at the limit of x times ln x as x approaches 0. So once again, first let's just try basic substitution. So 0, and the natural log of x as x approaches 0 is negative infinity. So it's going to be 0 times negative infinity. And remember, 0 times infinity was one of our indeterminate forms. So this is indeterminate. So we want to use L'Hopital's rule, but to do that we need it in the form of a fraction. So when you have a problem like this, what you want to do is you want to try and manipulate the function to express it in the form of a fraction. For example, you could rewrite x times the natural log of x as ln of x over x to the power of negative 1. It means exactly the same thing. And now it's in a form where we can actually use L'Hopital's rule. So instead of trying to find the limit of x times ln of x as x approaches 0, let's use L'Hopital's rule on the fraction that we've just created to try to find the limit. So we need to differentiate the top and the bottom separately. The derivative of ln of x is 1 on x, and the derivative of x to the power of negative 1 is negative x to the power of negative 2. And if you simplify that, you can turn it into 1 on x over negative 1 on x squared, which equals negative x squared on x, and that just equals negative x. So now if we try basic substitution again, you get negative 0, which equals 0. So that's the limit. Alright, have a go at trying to figure out the limit of x squared times the natural log of x over e to the power of x as x approaches infinity. Well, if you try basic substitution, you're going to get infinity times the natural log of infinity, which is just going to be infinity, over e to the power of infinity, which is also just infinity. So that's essentially infinity over infinity, which is indeterminate. So let's try using L'Hopital's rule. So to differentiate the numerator, we're going to need to use the product rule. and that's going to give us 2x ln x plus x squared times 1 on x. And the derivative of e to the power of x is just e to the power of x. So now if we try basic substitution again, we're going to get infinity times infinity plus x squared times 1 on x is just the same as x. So infinity over infinity, which equals infinity over infinity again. So still indeterminate, but we can keep going. So let's differentiate the top and the bottom again. So differentiating 2x ln x using the product rule again, we get 2 ln x plus 2x times 1 on x. Then differentiating x squared times 1 on x, which just equals x, we're going to get 1. And once again, the derivative of e to the power of x is e to the power of x. So let's simplify that first. We're going to have 2 ln x plus 2, because 2x times 1 on x is 2, and plus 1 over e to the power of x. And if we sub in infinity again, we're going to get basically infinity plus 3 over infinity, which is just infinity over infinity again. But we can see that we're making progress, so let's apply L'Hopital's rule again. The derivative of 2 ln x is 2 over x, and the derivative of 2 and 1 are both 0. And the derivative of e to the power of x is just e to the power of x again. So now if we do substitution, 2 divided by infinity equals 0, because a number divided by infinity equals 0. And e to the power of x is going to equal infinity. And remember that dividing any number by infinity gives you 0. So 0 is our limit. Right, here's a tricky one that's really common in tests and exams. What's the limit of x to the power of x as x approaches 0 from the positive side? I'll give you a clue. Turn it into y equals x to the power of x, and take the natural logarithm of both sides, and then go from there. Alright, so let's let y equal x to the power of x. And that means that ln y equals x ln x using the log laws. So let's evaluate the limit of ln y. Well, the limit as x approaches 0 from the positive side of x ln x, which equals ln y, can be rewritten as the limit as x approaches 0 from the positive side of ln x over 1 on x. Remember, we did this exact same thing earlier. And then if you apply L'Hopital's rule, you get 1 on x, which is the derivative of ln x, over negative 1 on x squared. That's the derivative of 1 divided by x. And that can be rewritten as negative x squared over x, which equals negative x. So if you sub in x approaches 0, you get a limit of 0, but that's for ln y. We want to find the limit of y. So the limit as x approaches 0 from the positive side of ln y equals 0. So if we can turn ln y into y, we can find the limit of our original function, because remember we set y equal to x to the power of x. So just using the log laws, if ln y equals a number, then y will equal e to the power of that number. So that means the limit of y is e to the power of 0, which just equals 1. And remember, we set y to equal x to the power of x. So that means that our answer is 1. Alright, here's one final example. What would the limit of sine of 1 over x be as x approaches 0? Let's start with basic substitution. If x is approaching 0, then 1 over x is going to become infinity. Because remember, x doesn't equal 0. It's just getting very, very small as it approaches 0. And a number divided by a very, very small number equals a very, very large number. So it approaches infinity. And then the denominator is just 0. Alright, so now we have sine of infinity over 0. And this doesn't actually become an indeterminate form, because sine of infinity doesn't approach a single value, it just oscillates between -1 and 1. So because sine of infinity doesn't actually approach a single value, that means that there is no limit. So the limit actually does not exist. So remember, just because you're asked to find the limit of a function divided by a function doesn't necessarily mean that there's actually going to be a limit. You might not even be able to use L'Hopital's rule.